как доклад будет на английском языке. И, в принципе, все, тогда мы продолжаем. Да. Бернд. Микрофон. Я вторым буду.
Нужен перерыв небольшой. Одного с микрофона ставить?
Да.
Основной голос у вас.
Основной будет Бернд. Нет. У нас сейчас давайте 5-минутный технический перерыв, мы переключимся и сейчас продолжим. Да. Five minutes. There it is.
Когда вы говорили про то, что есть база данных из активных заявок и исторических заявок, нет два
I have my own. Thanks.
Можно ли связать между собой, использовать данные из исторических заявок в активных? То есть если ты прям в команде нативно. Есть, да? И второе, меня очень волнует по производительности.
Производительность Camunda.
Okay.
Ну, можно сравнить с любой.
Yeah, no worries.
Вот эта вещь, которую она побеждает просто. Сейчас. They just 5 minutes go outside, come back and
No worries. Let me know when I start, then I start.
Да, сейчас тогда технически. Смотрите, сейчас вопросы, когда после выступления Бернда будут вопросы, и потом мы можем еще до 10 здесь время, мы на все вопросы можем обсудить, и я отвечу на него. Мы можем там второй поставить, здесь разбиться на кружки, у нас будет время.
У нас последний вопрос. Я правильно понимаю, что вы как организация делаете BPM решения? Если мы захотим наш некий сменить, мы можем вам сказать, как работать.
Да, конечно. Мы этим занимаемся, но коллеги с этого началось, мы с Рафаэлем Банком сделали проект, вот они поэтому начали Meetup. Мы этим давно занимаемся.
Отлично. Спасибо.
Hey. Oh, sure. On this one. Anything special?
Еще раз напомню, после выступления у нас будет время для того, чтобы задать вопросы. Если кто-то вопросы уже принес с собой, передайте, пожалуйста, Олегу. Те, кто смотрит нас в YouTube, тут же пишите свои вопросы. После выступления Бернд ответит на те вопросы, которые в комьюнити возникли, возможно, за то время, когда с командой поработали. Мы готовы начать. Часть на второй этаж. В принципе, говорить стараться. Я попробую переводить на русский язык по возможности.
Thank you. I actually don't understand anything from what you're saying at the moment, so, but I'm glad I'm here actually. Thanks for inviting me. It's quite impressive to see so many people here, so thank you for coming. And yeah, I want to talk about Zeebe. And you see I basically put all the buzzwords on the slide, so that's an important slide. The horizontally scalable cloud-native workflow engines for microservices orchestration. So my plan, do you want to translate? Or
I think I try to translate what you're saying.
Can we do like a quick show of hands? Who is capable of understanding my English, let's say? Okay, that's quite enough. That's pretty good.
Okay, let's...
yeah, probably we can go into some highlights because we're not all the people. I try to speak slowly, which is hard for me to be honest, but I try to. I'm not a native speaker too, so it shouldn't be too hard. Who am I? My name is Bernd Rücker. I'm one of the two founders of Camunda. I'm actually not CTO. I think that was in the announcement. It's called Chief Technologist, which basically means I'm thinking a lot about the technology and the use cases and the customers, but I don't have the operational stress of the CTO. So that's a much better role to me. If you want to reach out to me, you find me on Twitter. Here's my email address. Always send me an email. If you have questions, no worries. Just shoot me an email. I'm sometimes doing these kinds of talks, but I'm also doing proof of concepts from time to time. I'm trying to be at the customer. I'm trying to understand what they're doing with the technology, actually. So that's a bit of me. I'm basically doing workflow engines for all my life, at least my professional life. So for the last 15 years, actually more than 15 years, I'm working with workflow engines and contributed to various open source projects over time. So that's basically my personal history. And today I want to talk about Zeebe, and I basically thought I make it like a three-step approach. So the first is like, what is Zeebe? Why do we do Zeebe? And what's the difference to Camunda BPM, for example, and also how we do that. I will do a quick demo as well in the end so that you get the idea, I hope. It's a quick walkthrough, especially as most of you probably already know Camunda BPM. That shouldn't be too hard. And from what I got from the last talks, I think you already got a lot of the concepts. I used the visuals and some of the words I understood. And for the Russian thing, I'm not capable of. So what's Zeebe? It's we named a workflow engine for microservice orchestration. That probably sounds familiar, right? Camunda BPM is also a workflow engine. We now focus on the use case of microservices orchestration. What does that mean? So if you think of a certain workflow, a certain business process, a certain business capability, probably even provided as an own microservice,
you very often have to orchestrate other services in order to do that. And one way of doing that could be that you deploy such a workflow in BPMN. We still use BPMN and Zeebe onto, we call it broker. That's the workflow engine, basically. So you deploy it on the broker, and then you can have what we call workers, which might be either the microservices or it might be connectors then talking to the microservices in order to basically fulfill one of these services over here, basically corresponds to one of the workers. So it's very, from that picture, very comparable to Camunda BPM with external tasks. Okay, that's the basic idea. If you want to read more about that, I'm not really going into that detail too much. So I assume that you at least have some familiar, you at least know Camunda BPM to some extent, and you saw it in the last talks as well. If you want to read more about that, we have a quite good page actually explaining that in a lot of detail. So I want to spare the time. If you're interested, just go there and look it up. So in summary, it's a BPMN workflow engine. Hooray. It's cloud native and it's cloud scale. I go into that into more depth in a minute. That's actually the important part, where also the difference to Camunda BPM is. It's open source. Probably if you wonder why there's written source available, that's an interesting discussion at the moment with basically all the open source vendors. That's kind of, we changed the license in Zeebe, so it's basically kind of Apache license or MIT license, but, and there's a but, which basically says you're not allowed to provide a cloud offering competing to that. That's kind of the anti-AWS license, what a lot of the, like Confluent is doing and others are doing. And we're doing that as well, basically to protect us against being like the competition from big cloud vendors using their market position to, basically to dominate the market there. So that's why it's source available. It shouldn't affect any end user. So we're pretty sure about that. There's a good page on the Zeebe side explaining that if you want to discuss that. We just reached a production ready state, so we're developing Zeebe for like 3 years now. Internally, we did a lot of things for 5 or 6 years already to basically test certain aspects of that. We're now reaching production ready state and currently going into production with a couple of customers. So there's also an enterprise edition that's comparable to Camunda BPM. We're starting that, and we are starting to offer cloud service. Pretty soon, there's currently a closed beta program for doing that. Okay, that's the thing. So Zeebe is a BPMN workflow engine. So that, I mean, we already have one, right? Camunda BPM. It's a BPMN workflow engine. So where's the difference? Yes, we have these two engines, and from what they do from the outside, it's basically the same thing. Right? That's important. So it's both our BPMN workflow engine. But internally, they work very different. So there's a reason why we have rebuilt a workflow engine from scratch, and Zeebe is really developed from scratch new. Camunda BPM bases on a relational database. So we basically have a couple of tables where we store the state, right? And we update the state and so on and so forth. Zeebe is built differently. In Zeebe, we leverage something you can easily imagine like an event stream, basically. So we have kind of an event log where we store things basically also on disk. And that, I go into that on the next slides. And that removes the necessity for having a relational database. Right? I go into more details of that in a minute. Okay, that's important. So that's basically how we implement the engine is very different. What it does, it's kind of comparable. Why do we do that? What's the reason for doing that? So if you have that pattern, which we had for like 10 or 20 years in the industry, like we have an application, we have the relational database. Right? That's a very good pattern actually, and the relational database can do a lot of things for you. But the problem is it's not really scaling very well. It's not very resilient. It's very expensive to make a relational database like highly available. You have to throw a lot of money at that to get that running, right? So whenever you have use cases where you really need very high throughput or having high performance requirements, or probably run in an environment where you don't have a relational database, like very often in Kubernetes environments, for example. It's not that easy to have that relational database. I made that I'm very proud of that animation. You can see that the relational database doesn't fit in Kubernetes. In neither way, right? It doesn't fit in Kubernetes. And that's one of the reasons why we said, okay, we have to do things differently for future use cases. And there are a lot of use cases. So nowadays, I mean, we do a lot of like, whatever, order fulfillment or application processing or whatever, account opening. There are use cases which run, let's say, 100 times per day, or probably 10,000 times a day, right? So we have certain load on the platform. We have customers doing quite big things with it, actually bigger than a lot of people think that a relational database can do. But we want to get much further. We want to get to use cases where, like, you don't only have bank account opening, but you have every money transfer, every trade, every phone call you make. There are use cases for workflow automation. And then you have like hundreds or millions of instances per second for some of these use cases. And that's not what you can do with a relational database. Or if you want to replace whole, like batch processes on a mainframe, the argument is typically, hey, we can't do that with that relational database thingy. That's a toy. You can't do serious things with that. And we want to get to that level. And that's basically why we build Zeebe. How do we do that? So the traditional model of a workflow engine is more or less like that. In Camunda BPM, if you start a workflow, it works like that. Hey, here we kick it off, and that means we have some row in a table. It looks a bit different, to be honest, but more or less like that, where we basically know, hey, this is the current state, right? Everything is okay. As soon as we move on, we basically update that current state in that table, and so on and so forth, right? We write a couple of additional things for the audit and whatever, but the core idea is like that. You update the state in that table. If we do it with the event log in Zeebe, then it looks a bit different. It's like, hey, we want to kick off a new workflow instance, and that basically means we send a command into the log and says, hey, we want to create a workflow instance. And then a couple of events are written because, hey, the workflow instance needs to be created, whatever, the start event occurred, which is the first thing here, sequence flow probably was taken, and so on and so forth, right? You can imagine it like a sequence of events. And we write all these events to the log. We don't update anything. That's a big difference of a log. It's append only. We just write to it. We just append things, right? And then the current state of the workflow is derived from that log, right? You can't come in here and say, hey, what's the current state? You have to reread the log basically in order to know the state. I come back to that in a second. That's also known as event sourcing very often. So that's what we do in Zeebe internally in order to capture the state, and so on and so forth. Actually, again, it's a bit simplified. The real events are named a bit different, but that's more or less the idea. Okay? Good. And then we have to do a couple of things around that in order to make it work. So the first, let's assume you want to, what did I use? Complete a task, like one of the activities in a BPM workflow. You want to complete that. So I send in a command. It's appended to the log. Then the first thing, and that's interesting, it's written to disk. So we use the local disk. It's kind of a binary format. We just write it to the local disk. So we don't need any database. We don't need anything external. It's written to disk, right? Then it's replicated. That's another interesting thing. Whenever you use Zeebe, you have a couple of brokers. Not only one, but you have a couple of them which use that leader-follower principle and the Raft protocol. I'm not sure if you're in distributed system. Raft is very often known. But basically it means we have a couple of followers and we replicate the state to them. So that also means whenever one of these brokers dies, we still have the state, right?
So basically all of them have them on disk. That's also important for resilience. So you don't rely on that central database, and if it's down, you're dead. No, you have all the brokers, all of them have the state, and they replicate. Next thing we do, as soon as it's replicated, that's kind of the commit. We wait for that to happen. We wait for all the followers to acknowledge, hey, we got the information. Right? We wait for them. As soon as that's done, we process that command. We say, hey, okay, he wants to complete the task. And now we need to know, hey, what's the workflow instance, where it's currently at? Can I complete the task, and so on and so forth. That's why we build internal state. So every broker uses kind of a key value store. In this case, it's RocksDB, probably you know that. It's from Facebook, and it's kind of an embeddable, very efficient key value store. And that means we write a couple of entries there, like, for example, for the workflow instance, we know the current state, or a couple of other things, right? So with that state, we can check, hey, is complete task currently possible? And if yes, what should happen? And one of the tricks, and that's an important trick actually, is that this uses a so-called single write-up principle. So it's a single thread, independently how big your cluster is. I come back to that, how you scale out then. But it's always one thread, and that removes the burden of making some kind of locking or a kind of detection for parallel writes or whatever. That's what the database normally does for you. We don't need that because we know that's one thread. We always have a clear sequence in which we execute. Okay, so we do that. Then we can tell the client, hey, all good, we're done. And then we append probably new events like, hey, okay, the complete task is completed, we go that sequence flow, this activity is entered, and so on and so forth. Okay? That's basically the execution loop which happens in the background. And that's the basic idea behind that. It's pretty different to how Camunda BPM works. And it enables a couple of things. Right, and then we, of course, if we append events here, we also replicate them to the followers. Okay. I talked about a single thread. And that means if we have, and this line is now a leader, that's the broker which really does things, and then everything is replicated to the followers. Then only one thread is doing the work. How does that scale, right? And the thing is we are using what's called partitioning. Kafka does the same thing, other tools do the same thing. Mongo talks about not partitions, but shards, I think, but that's what distributed systems normally do. We do partition, and that basically means you can run multiple partitions, and then one workflow instance is always put into exactly one partition. And we make that even part of the workflow instance key, so everybody in that game knows on which partition it lives. And now we can make as much partitions as you want, and that probably matches the number of cores or broker nodes you have in your cluster. And that means, I mean, we run test cases, for example, on Google Cloud with, like, what was the last one, with 86 really big machines, and then you can run like 200 partitions, that's no problem, and then you really scale out with that system. And that's something you couldn't do with Camunda BPM. Okay, one last thing, and then I quickly want to jump into the demo. One challenge of this architecture, as we only have that event log, we don't have a database. The database was cool, you can ask queries to the database. Hey, what workflow instances do I have? What workflow instance do I have in that state, or something like that? We can't ask the event log questions. It's just not possible. And that means we need something which is kind of very often known in a way as CQRS, command query responsibility segregation. That's a pattern pretty known in the event sourcing world. And it basically means we export the whole stream of events, the whole log, to Elasticsearch, and then base the monitoring onto the Elasticsearch, because there we can ask queries. Right? So that's the whole architecture. The broker is doing the whole runtime, scales out, streaming all the events out to Elastic, and there we can ask questions. It's, by the way, easy to hook an own export.
and then you can stream the whole event stream to wherever you want, if you do like additional things, data lakes or whatever. Okay? And then we have like the tooling around, right? So if you look at the architecture, that's basically it. That's also what you find in the documentation. So we have these brokers, right? They form a cluster and replicate amongst them. We have the exporter to Elasticsearch, and we have operate. That's kind of what in Camunda is called cockpit. It's called operate in Zeebe to look at the stuff and doing operation things. And then another interesting part is, and then we have so-called gateways. That's not too important at the moment. The gateways are kind of translating between your client, and come back to that on the next slide, and the broker topology. So if you, for example, run in something like Kubernetes, then you don't need to know all the broker topology from the outside, right? So they just run within there, and you just need one address to the gateway. It's kind of like an API gateway in the whatever serverless world, right? And that's also important. We're talking gRPC to the client. So the model is a bit different. In Camunda BPM, you could have like a Java engine, a jar, which you embed in your own application. The model here is different. Zeebe runs on its own, and then you have a client to connect to it. It's kind of a JDBC driver for databases. You have the client for Zeebe. The cool thing is that as we're talking gRPC, you can generate clients for basically every language. So we already have a Java client and a Golang client in the official distribution. We already have contributions for a Node.js client, a Rust client, a C# client, I think one or two more, right? So it's pretty cool that you can really go polyglot with that. How does it look like if you build your own application? So if you have that Zeebe broker over there, what I said earlier on, you have the client, you embed that into your application. I'll show that in the demo with Java in a minute. So it's basically jar, a Maven dependency, for example, to have the client. It talks to the broker. And in your application, right, the broker, by the way, is written in Java, still, just in case you're interested. You define in your application, you define your BPMN model. That didn't change too much. Then it's deployed to the broker and executed there. Okay, I think that slide doesn't help too much here. And then the interesting part is whenever you have a service task, it's like external task in Camunda BPM, you define some code here which basically subscribes to Zeebe that it can do, like in this case, B. Okay, it's kind of a pub/sub mechanism. Okay, that's the whole idea. Right. Shall we look at that? Yeah? We're in the time, we're good in time. Awesome. Okay, let's see how that goes with the mic. So, hello computer. Why is that gone? We're back in a second, I think. That's a PowerPoint trick. Shouldn't do that. But it still does it. It doesn't duplicate. There we go. I'm on it. Yay! Thank you, Windows. There we go. So, what we can do, and we start from scratch, I think. What I have running here, let's delete these three guys and start from scratch. What I have is a Maven project, hopefully readable for everybody. So it's just a Java project. The only thing I did is I added dependency for the Zeebe client. That's the only thing I need in that project. So that's pretty neat, actually, pretty thin. Then I can define a BPMN model. So that's probably not surprising. We have a modeler for that. So that's based on the same technology as the Camunda BPM modeler. We have to catch up with the latest version, so it's a bit older actually from the basis, but that's soon to be resolved. Then we do something. I'm quite uncreative at the moment, so we make it very simple. Well, Using 2 keys and holding the microphone is easy. So do something, then we have a type. I call that do something, probably. That's kind of like, if you know Camunda BPM, the external task, that's the, also the task type we're using there. That's more or less the topic name we use there. And I want to use a message ingestion. I'll come back to why I want to show that in a second. So we define a message here where we say, hey, that's the message test. And that should correlate. We need some information to correlate to find the right workflow instance, and I'm using some variable here. Or we use something which is probably more easy to understand, something like an order ID, if that's an order fulfillment workflow. Okay, and then I name the process Moscow and make it executable. That's the same thing as in Camunda BPM. So we're basically done. We defined our first workflow for Zeebe. That was easy. So far, it was pretty similar, I think. What I do now, 2 things. The first is I run Zeebe in the background. Is that readable? Not really, right? Is it? Can you read that? Yeah? Okay, cool. I use Docker actually to run it here. So let me show you that. If you go to Zeebe, you can download it, so you can basically either get some Docker run command, or you download a zip file if you prefer that. So you basically can just download it. The neat thing is we also provide a couple of Docker Compose configurations to start a certain configuration. Like what I said earlier on, probably I want to export it to Elastic and then have operate running. So you have to start Elastic and operate. In order to make that easy, we have a couple of Docker Compose files here. And one thing I started is the so-called simple monitor. So I get Zeebe, the core broker. I get an H2 database, which is basis for the web application showing the things. That's not a production environment. Don't do that in production, right? But it's cool for demos. So that's what I do here. I just started that. And then you have something called Zeebe CTL. So if I download the zip file and unzip it, which I did here, you get a Zeebe CTL file. And that's a command line tool where you can do things like, for example, I could say status to ask my local Zeebe, hey, what's currently going on? I have a cluster of 1, only replication factor of 1, so that's pretty, for development that's cool, for production probably not. And then I can also deploy things like deploy, where I source, main. I'm not saying that this is the normal way of doing it. Resources, and then I called it Moscow, right? Right, so I can deploy the workflow I just defined. I get back acknowledgement, it was deployed. I can also deploy via Java, or you can use the Spring Boot stuff. So that's very comparable to what you can also do in Camunda BPM, but I wanted to show that way. And then what I can do, I can use that simple monitor. That's really a simple web application where you can see what's going on. And then I see, okay, I just deployed that workflow. Okay, nothing going on there, but it's there. That's cool. And then let's switch back to Java. I could deploy here as well, but I'm doing other things here. Now let's start some workflow. So now it gets really start workflow. Sorry for that. So there we go. Public. I'm missing my left hand actually, so bear with me. Void main. Sorry. There we go. Yay, that's cool. What I can do now is I can say Zeebe client, Zeebe. That's Eclipse now. That's a normal picture of Eclipse, right? Zeebe client. Yeah, I should definitely switch to another IDE, but I'm too lazy to do that at the moment. So there we have Zeebe. That's everything you need. You could specify like the endpoint, like an URL, IP, or whatever. But for localhost, that works out of the box. Then I can do things like client, new workflow instance, new. There I could deploy, by the way. New create. That's create instance command. I can specify which BPMN process I wanna start. That's Moscow. I can say which version I want to start. I can provide some variables, which I will do in order to make the singleton map, and then I name that order ID. Wow. It's really not that easy to type with that mic. Let's say 1, 2, 3, 4, 5. Right. So that should be probably it. The interesting part as well here, so you see it's kind of a chained interface. I have to send that. So it's kind of the command we're building, and then I send it to Zeebe. And what you get back, that's also interesting. You get back a future. And the idea here is that this is a non-blocking call. So we're going to the broker, basically send over the command. So if you remember back that picture, we're sending the command, but we're not blocking. So we can do other things. And the future is basically triggered when this response comes from the broker, which might be later on. So this might add latency. But in my case, I want to wait for it, actually. So I do something you should do in every demo. Where's this out? Future. And then what's with future? Join, I think, right? Right. So that should actually start a new workflow instance. Let's try that. So in the background, it connects to Zeebe, starts a new workflow instance, and that should be it. Yeah. Oh, damn it. I still have something working from my try run early on. But no worries. You just do a different number, 2, 3, 4, 5, 6, and start a new instance. So as soon as we do that, what we can also see, if I go to the simple monitor, it's probably not too surprising. We see 2 instances already passed. One is currently still waiting and to do something thing, right? One is currently waiting for that message. How does that work? With a worker, and that's one of the things which is a bit different to Camunda BPM. Let's make that a bit quicker. So sorry. Next time I bring my stand for the microphone with me. Worker. So let's do that. I have a worker here, and now the thing is, I go for client, new worker, basically defining which job type. That was, I think, do something, right? Right? Thanks. Then I define a handler, which is basically the callback, right? And then I open that. Sorry, I open that. That should be okay. And then I do some whatever code you need, right? That's a bit like what you do in the Java delegates in Camunda BPM, but it's really like a callback. It's really like, like reactive here. I do some whatever, hello. And then what I have to do is I actually, okay, arc0, thank you, Eclipse again. But we do that now. And now basically tell the Zeebe that I completed that, arc1 get job ID, get key, sorry. So, and send that over the wire. That's just telling the workflow engine, hey, this task completed, and this is what I do. It's kind of comparable to what you write in Camunda BPM, but it's really the whole environment, how it's called, is very different. And as soon as I start up that worker, it should pick up work. And I think I'm more or less out of time, right? Give me 1 second. Right, so that writes hello. That's pretty cool. Right, and now 2 are waiting here. The interesting part is that as soon as the worker is running, if I start new instances, they're started, and the worker is running, so it immediately executes this thing, so the 3rd instance directly moves on. And you can scale up the workers, and you could even have workers doing the same thing in different programming languages. It doesn't make too much sense, but technically no problem. So that's pretty interesting here. And the last thing, and then I'm more or less done, is because, well, yeah, what the heck, don't worry. Put it here, send message. If I send in a message, and that's actually very different to how we handle it in Camunda BPM, that's why I'm highlighting that here. And we have a big customer. For them, this is one of the main features why they want to switch, actually. New publish message command. What's the message name? What was that? I forgot it. The order ID was for correlating. Message test was the name. Message test. Then the correlation key, that was indeed the order ID. So we should have one with 1, 2, 3, 4, 5, I think. And then I should be able to send it. And I always make a sysound around that in order to see something. So, just for the demo. Wow. There we go. That should actually send the message to Zeebe. And let's see what happens. So that should actually work. I'm confident that it worked, actually. I sysed out the future, which doesn't make too much sense. I should wait for the result. So if I go back here, I now send in a message. What we see is nothing. Okay, that's interesting. Let's check again. Do we have a problem here? 1, 2, 3, 4, 5. Which looks, oh, null. Null is not too good. Say it again. We have the message name, we have the correlation key, we send it, and we join. That's okay. 1, 2, 3, 4, 5. Did we start a workflow with 1, 2, 3, 4, 5? Order ID. Yeah, probably the yeah, right. The other workflow had a different variable name. Good. So let's send in that one. That should actually trigger something. So that's done. Let's go back. Right, so all of them are actually triggered. That's also one difference. So for us, message correlation now is a 1-to-n thing, so it can trigger multiple workflows if they have the same workflow variables. Another thing, and that's even more interesting. So let's do, 47. So, if I send in that message, we don't have a workflow waiting for it, right? But Zeebe basically accepts the message. We have a time to live for messages, which you can configure. And now if we start a workflow with 47, the interesting thing is, as soon as we do that, this one, let's see, there we go. This one immediately moves through. So the message was before the workflow, and that's perfectly fine. We can buffer the message. And that eases a lot of the message patterns we see in distributed systems. Because very often if we collect multiple messages, they might be faster than other things, and so on and so forth. Okay? So that's actually pretty interesting as a detail. That was just a very quick demo, but I wanted to give you an idea of how that works. The most asked question then typically is, okay, what should I use now? You know, you have that 2 engines. What makes sense for me? And currently, what we do is our default is, if you have really a cloud-native scenario, if you're running Kubernetes, or if you want to really scale out, right? If you do, so that's one of the things. If you do microservice orchestration, so if you do, for example, human task management, we don't have a lot of support in Zeebe yet, so that doesn't make too much sense, and normally you don't need that much scalability for human tasks anyway, right? Or if you want to run a managed service, if you want to use a managed service provided by us, then Zeebe definitely makes sense. So there are a couple of triggers when you probably want to use Zeebe, but in all other cases, currently the default is to use Camunda BPM. Why? The maturity here is not as high as here. So you don't have that many features in cockpit. You don't have that many BPM end symbols being supported. You don't have, I could compile a quite extensive list. So it's much more smoothly to be on that side. But whenever there's a good trigger, a good reason to go for Zeebe, do it. If you start a new project, there are a couple of tricks how you develop on Camunda that a potential migration, not sure if you ever do it, but a potential migration might not be too hard, like using external tasks all over the place. That's a good idea, right, for example. Okay, that's more or less it. That was a very brief intro. Thanks for listening.